Hi friends, this is Naresh. In this class, I am going to explain about how to locate the centroid or center of gravity of an L section and T section. First of all, I want to explain about importance of centroid in real life. Centroid plays an important role in design of civil engineering structures, automobile parts, and mechanical machineries like buildings, dams, irrigation structures, RCC structures, foundations, water tanks, bunkers, cars, buses, like this. The position of center of gravity is very important because the stability of structure depends on center of gravity. So in this class I want to find out the centroid or center of gravity of an L section. The question is here. Look at the center of gravity of the given L section. The dimensions of an L section are 20 mm thickness, 100 mm base, 80 mm height. First of all, the given L section is split up into two small rectangles. First one is horizontal rectangle. The dimensions are base B1 equal to 100 mm and depth or height D1 equal to 20 mm. Another rectangle is vertical. The dimensions are base 2 equal to 20 mm and height D2 equal to 60 mm. In this slide, uh, A1, A2 are the individual areas. A1 is the area of a bottom rectangle, that is B1 into D1. Therefore, A1 equal to 100 by 20 equal to 2000 mm square, and A2 is the area of a vertical rectangle. Dimensions are B2 equal to 20 and D2 equal to 60. Therefore, A2 equal to 20 by 60 equal to 1200 mm square. Now, I am taking the reference axis. The centroid of a body is calculated with a assumed reference. There is no set rule for selection of axis of reference, but in general practice the axis reference is the bottommost line of the figure for calculating the y bar, and edge of left edge line of the figure for calculating the x bar. Because of this practice, the entire figure lies in first quadrant and the values of x and y becomes positive. First of all, the center of gravity of a parallelogram or a rectangle is at a point where its diagonal meet each other. Therefore, C1 is the centroid of a bottom rectangle, and at a distance of x1 from y axis and y1 from the x axis. Similar way, C2 is the centroid of a vertical rectangle and at a distance of x2 from y axis and y2 from x axis. Therefore, x1 equal to half of the base of a bottom rectangle, that is b1 by 2 equal to 50 mm, and y1 equal to half of the height of a base rectangle. So therefore, y1 equal to d1 by 2 equal to 10 mm. Similar way, x2 equal to half of the base b2 by 2, y2 equal to half of the height plus height of the bottom rectangle. Therefore, d1 plus d2 by 2. All these values are written in tabular form, where xc is the distance of center of gravity of an entire section from y-axis, and yc is the distance of center of gravity from x axis. The general expression for centroid is xc equal to a1 x1 plus a2 x2 by a1 plus a2. Therefore, the answer is xc equal to 35 mm. Similar way, yc equal to a1 y1 plus a2 y2 by a1 plus a2. Answer is yc equal to 25 mm. Now, here I am showing the location of center of gravity. Here C1 and C2 are the individual centroids, whereas CZ is the center of gravity of an entire L section at a distance of xc from y-axis and yc from x-axis. Coming to the next problem. Here you can observe the dimensions of an inverted T section. The dimensions are 100 mm base, 20 mm thick, and 80 mm height. It can also, first of all, you can split up into two rectangles. First one is horizontal rectangle. Dimensions are b1 equal to 100 mm, d1 equal to 20 mm. Another rectangle is vertical. Dimensions are b2 equal to 20 mm, d2 equal to 60 mm. Now I am calculating the areas, individual areas. Therefore, A1 is the area of a bottom rectangle, that is A1 equal to B1 into D1 equal to 2000 mm square, and A2 is the area of a second rectangle, that is A2 equal to B2 into D2. Now I am considering the reference axis, x-axis and y-axis. Now I am drawing the diagonal lines to locate the centroid. C1 is the centroid of a bottom rectangle at a distance of x1 from y-axis and y1 from x-axis. C2 is the centroid of a vertical rectangle at a distance of x2 from y-axis and y2 from x-axis. From figure, x1 equal to b1 by 2, y1 equal to d1 by 2, x2 equal to x1 equal to b1 by 2, and y2 equal to d1 plus d2 by 2. All these values are written in tabular form. Now, similar formula, x equal to a1 x1 plus a2 x2 by a1 plus a2. The answer is x equal to 50 mm and yc equal to a1 y1 plus a2 y2 by a1 plus a2. Answer is yc equal to 25 mm. The final location of the centroid for T section, inverted T section, is C1, C2 are the individual centroids of an T section. CZ is the centroid of a entire T section at a distance of xc from y-axis and yc from x-axis. We can solve this problem by using symmetric axis condition. So I am taking same problem. The main difference is I'm taking the y-axis at mid part. It means symmetric about y-axis. Given T section is symmetric about y-axis, hence the centroid lies on symmetric y-axis only. So therefore the values of x1 and x2 are 0. Here we can observe it. X1 and x2 are 0, y1 equal to d1 by 2, y2 equal to d1 plus d2 by 2. Here same formula, x equal to 0 and y equal to 25 mm. So the final position is same, there is no change in position. The main difference is reference y-axis. Okay. In next class, I will explain about how to locate the centroid of an I section and T section. Okay, thank you.